Today we're looking at an application of the theorem, fundamental theorem of calculus theorem. So here it is over here. Remember, we use it to find the area under a curve. So you've seen this before. It's just now they just go and play around with the variables here. So let's have a look at a question. Determine the exact value of A if the integral of 1 over x minus 1 equals 2. So equals 2. So they give you the area on the right-hand side. X can't be 1 because remember, if x is 1, it makes this denominator 0. So that's just good maths, giving that restriction. And they also tell you then that A is greater than 3. So that bound is greater than 3. So let's have a look. So let's see what we can do. So working with the left-hand side, if we apply the fundamental theorem of calculus, we will integrate our reciprocal function there, and that's just integrates to ln of x minus 1 using your rules with the lower bound, the upper bound, and that's equal to 2. Right, then we're going to sub in the upper bound, take away, sub in the lower bound, 3 minus 1 is ln of 2, and that's equal to 2. And then I can use a log law on the left-hand side. So ln is equal to a minus 1 over 2 equals 2. And remember, you're trying to solve for a. So it's in log form. I will rewrite this now in index form. So that will be e to the 2 is equal to a minus 1 over 2, writing it in index form, and then multiplying by 2 both sides, and then taking over the 1. And there we go. That is A as an exact value. So you're obviously in a tech-free paper here. So you'll stop over here because you do not have a calculator. Right, have a look at these two practice questions. They're both from schools, local schools. The first one I've changed to complex familiar. I don't believe that's an unfamiliar question. And the second one is sort of an unfamiliar question. And again, I really need to know your triangles, your special triangles, and the boundary angles for the rest of this course, basically. So you need to know that inside out. Right, see how you go.